Hello students. So we will discuss about the natural consequences of high speed specific latent. Okay, so this will be our sixth video of physics. Okay, chapter 1, class 8. Okay, so you can, all of you, you can open the page number 17 of your book. Okay. So we will continue from this topic. So natural consequences of high specific latent heat of ice and steam. Okay, so latent heat, we have discussed about the latent heat. What is latent heat? It is the heat which changes the state, not the temperature. Okay, so first natural consequence is our natural consequences of high specific latent heat of ice. Okay, the first thing, ice, that means we are considering the solid. So soft drink bottles cool better in ice than at 0 degrees Celsius. Okay, you need to remember this. That is all the soft drink, either Coca-Cola, Pepsi, or anything, Sprite, Mirinda, anything. Okay, they cool better in ice than at 0 degrees Celsius. Why? Because every gram of ice at 0 degrees Celsius extracts out 336 joule of heat energy. Heat more than water at 0 degrees Celsius. That means the ice is again at 0 degrees Celsius. Both the temperature were same. Okay, ice is also at 0 degrees Celsius, and your temperature if water is also at 0 degrees Celsius. Okay, but what we have extra thing in ice, that your 0 degrees Celsius of ice extracts 336 joule of heat energy more than water. Okay, suppose your water extracts some amount of energy and ice extract more than 336 amount of energy than water. That's why the soft drinks of bottle cool better in ice than in water. Okay, similarly weather becomes warm during snowfall. During snowfall, we can see that the weather becomes warm. Why warm? Because every gram of water at 0 degrees Celsius on freezing gives out 336 joule of heat energy. Okay, and owing it high specific latent heat of ice, and as very large amount of heat energy is released, so that's why when the your water droplets forms ice, that means the water is releasing 336 joules of energy, and that 336 joules of energy is released in the environment, and that causes the weather to become warm. Okay, and weather becomes very cold when snow starts melting. Whenever you go to your something, suppose icy areas, okay, where snowfall is there, though when you will go, when ice is melting, then you will feel more cold. Okay, or the weather is more cooler. Why? Because now the water is freezing, okay, to ice. Temperature is same, 0 degree to 0 degree, but the ice is extracting 336 joules of energy. Okay, it is extracting, or it is, yeah, it is extracting 336 joules of energy from the environment. That means it is becoming more cooler. Okay, your environment is becoming more cooler. So it is because every gram of ice at 0 degrees Celsius extract out 336 joule of heat energy from the surrounding on melting from water to ice. Surrounding on melting to form water at 0 degrees Celsius, and as vast amount of heat is extracted. Now heat is, startingly the heat was released when during the snowfall. Okay, but when ice it starts melting, it extracts the 336 joule of energy. That means the temperature is extracting by the ice. That's why the weather becomes cooler. Okay, glaciers fed rivers flow throughout the year. Okay, so ice on glaciers melt slowly, as every gram of ice on melting to form water at 0 degrees Celsius requires 336 joule of heat energy. Thus, summer or winter, in case of summer or in case of winter, the ice on the glaciers does not melt completely. Okay, some portion is still there. That's why such rivers continuously flow throughout the year. The rivers which originate from the glacier, they continuously flow throughout the year. Okay, in any month you cannot see that it has when it stop flowing. Okay, why? Because either it may be summer or winter, ice is still present on the glacier. It does not completely melt. So iceberg sometimes reach equatorial region in the sea. Okay, the huge ice shape of ice sometimes reaches equatorial regions in the sea. Why? Ice has the highest specific latent heat capacity, and that is our 336 joule per gram. Thus, when a large size glacier is picked up by the ocean currents, or when the icebergs starts flowing in the direction of the ocean currents, it melts slowly because huge amount of heat required it to melt it. Okay, and in such a situation, some big icebergs manage to reach without completely melting. They manage to reach the equatorial region. Okay, so these are all the natural consequences of the high specific latent heat of the ice. Now we will move forward to the natural consequences of high specific latent heat of the vaporization steam. Okay, steam, if you boil the water, the vapors, okay, or the steam, that one. So we know that steam is more hotter, or it is hotter than the your fire. Okay, so first natural consequences is steam is used as a fluid in thermoelectric powerhouses. Okay, steam, where it is used? It is used in thermoelectric powerhouses to generate electricity. Steam is used to generate electricity in thermoelectric powerhouses. Coal means the koila. Okay, you can see in the uh, uh, you can see in the iron shops where they melt it and shape into different forms. Okay, they use coal is used and for a source of heat, and that coal is used to form the steam from water, and the heat of burning of coal is used to raise steam, which has the highest latent heat of vaporization, and that highest latent heat of vaporization is 2260 joule per gram. In 1 gram, okay, it can gives us 2260 joules of energy, and as no other substance can carry as much as heat per gram as the steam. You can see in 1 gram of ice, it can contain 336 joules of energy, but in 1 gram of steam it contains 2260 joules of energy, highest in the segment. Okay, so therefore steam is used to run the turbines. The steam produced, okay, that is used to run the turbines, and after turning the turbines we can generate electricity. It is the heat energy carried by the steam in the bulk in very huge amount, which turns the turbine that are coupled to electric generator. Okay, turbines are connected to electric generator, and when the turbine rotates, after the rotation electric field is generated. Okay, and that creates electricity to produce electricity. That means we are using the steam energy to produce electricity. Okay, number 2, burns caused by the steam are more severe than the burns caused by the boiling water or boiling hot water. Okay, as I have already mentioned, that steam contains more energy or more heat at as compared to your fire or boiling water. Okay, so steam has highest specific latent heat. This value is 2260 joule per gram. Hence, every gram of steam at 100 degrees Celsius will deliver every gram, okay, of steam at 100 degrees Celsius will deliver 2260 joule of heat energy, more than the water at 100 degrees Celsius. Okay, so boiling water that is at 100 degrees Celsius, that will provide less heat, as the steam will contain 1 gram of steam will contain 2260 joule of heat more than the boiling water. Okay, so that's why excess heat energy of steam is caused severe burns, okay, on the skin. Now we need to learn about the change of states. Okay, we have already discussed the change of state: solid to liquid, liquid to solid, again solid to gas, or gas to solid, or liquid to gas, or gas to liquid. Different forms were there. Okay, I have already said, told to remember that. Now we will discuss in details to change in state. Already discussed what is change in state, so you read it. Okay, you will get it. Fusion or melting. What is fusion or melting? It is the process due to which a solid changes into liquid state, but at some fixed temperature by absorption of heat energy, is known as melting or fusion. When solids changes into liquid. That change at some fixed temperature due to the absorption of heat energy is known as fusion, or we can say it's melting. For example, 0 degree Celsius, ice at 0 degree Celsius, on absorption of heat, when it absorbs heat, okay, it changes to 0 degree water. That means the solid ice is converting to liquid water. Okay, ice solid converting to water, that is liquid. Okay, how? Absorption of heat, and that process is known as our fusion. Clear? Next, fusion point. Okay, fusion point or melting point. Now here we will discuss about fixed particular temperature. So fusion point or melting point, it is the fixed temperature, either 0 degree or 1 degree or 2 degree or 3 degree. It is the fixed temperature at which solid changes into liquid state due to the process of fusion. That point is known as our fusion point or melting point. So you can see that 0 degree Celsius is the melting point of ice, because at 0 degree Celsius only the ice melts into 0 degree water. Okay, that 0 degrees will be the melting point or the fusion point of the ice. Fine. Next, the freezing or solidification. Freezing or solidification means that it is the process due to which the liquid, okay, liquid changes into solid state at some fixed temperature, but here energy is not given, not absorbed, whereas energy is released. In fusion, energy was absorbed. Now in solidification, what we will have, the temperature will release, okay, or heat energy will release, and it is known as solidification or freezing. Okay, so again, if you read it, the process due to which a liquid changes into solid state at some fixed temperature with the release of heat energy. So when heat is released, it is a cooling effect. We see the cooling effect. Okay, whereas when heat is absorbed, some hotness is there. That is known as solidification, and that point will be known as our freezing point or solidification point. It is the fixed temperature at which the liquid changes into solid state due to the process of freezing. That point will be known as freezing point. Suppose we can say that 0 degree Celsius is the freezing point of water. Water is liquid. Okay, so if we release the energy, so suppose temperature is decreasing, when it comes to 0 degree Celsius, then that water becomes liquid, solid. Okay. Similarly, we have the vaporization or boiling. Vaporization or boiling means conversion of liquid to gas or vapors. The process due to which a liquid changes into gaseous state at some fixed temperature with the absorption of heat energy. With the absorption of heat energy, the liquid gets converted into a gas. Okay, and that is known as our vaporization. And the temperature at which the vaporization occurs, that point will be our boiling point. Okay, the fixed temperature at which the liquid state changes into gaseous state due to the process of vaporization is known as your vaporization. Okay, boiling point, your vaporization. And we know that water becomes vapor at 100 degrees Celsius. So 100 degrees Celsius will be the vaporization point. 0 degrees Celsius will be the freezing point. 0 degrees Celsius will be the melting point of ice, like this. Okay, so you have to remember this also. Water, that is liquid, absorption of heat, that process is known as vaporization. It converts into steam, and that is gas. Okay, so next is our condensation. What is condensation? It is the process due to which the gas changes into liquid. Okay, now if gas changes into liquid, this process is known as our condensation at some fixed temperature with release in energy. Okay, energy will release and it get converted into liquid. Okay, and the temperature at which the gaseous state of matter changes into liquid state of matter due to the process of condensation, that point will known as our condensation point. Okay, we can say that 100 degrees Celsius. Okay, so 100 degrees Celsius changes into water. Okay, steam at 100 degrees Celsius changes into water due to the process of condensation, and hence condensation point of steam is 100 degrees Celsius. Okay, so at 100 degrees Celsius, water converts to steam, and at 100 degrees Celsius, the steam condenses to liquid. Okay, so next we have the sublimation. Evaporation. So evaporation, it is the change of liquid state into its vapor state at any temperature. Okay, evaporation. Vaporization is different from your Evaporation, it is the change of liquid state into its vapor state at any temperature below its boiling point. Okay, so evaporation means suppose at 100 degrees Celsius water starts boiling. Okay, that will be your vaporization. Okay, but evaporation, what is that? We will heat the water below 100 degrees Celsius, and below 100 degrees, if we continuously heat the water below 100 degrees Celsius, its vapor is it will form some vapors. Okay, not only water, some other liquid also, it will form vapors. That point at which it starts converting into vapor from liquid to vapor state, that temperature or that process is known as evaporation. Okay, but in case of your vaporization, the process due to which the liquid changes into gaseous state, it was the gaseous state. Okay, and you can see in the evaporation it is into the vapor state, but this state will be at any temperature, but it would be lower than the boiling point. Okay, that this will be the temperature below the boiling point. Okay, for example, water vapor are always present in air in variable amount. Okay, you can say that's why we feel humidity. Air is less humid or it will be more humid according to the water vapor contained in the air. Okay, so the temperature, our environmental temperature does not reaches 100 degrees Celsius, because if it reaches 100 degrees Celsius we cannot survive. No one can survive here. Okay, but below 100 degrees Celsius, that is the below the boiling point of water, at still some water vapors are present in the atmosphere. That is our evaporation. That is the change of, because when sun rays fall on the river or any water, it starts converting into vapor. Okay, but that temperature does not crosses the boiling point or does not reaches the boiling point. That temperature will be lower than the boiling point. Okay, so at the temperature lower than the boiling point, the water get converted into vapor state. That process is known as evaporation. Okay, and next we have our sublimation. Sublimation, when solid substances like your naphthalene, you can see naphthalene is there, or kapoor, we put in the in clothes. Okay, small white color marble type. So when a solid substance like naphthalene or ammonium chloride, iodine or camphor are heated, they do not changes into liquid state. Okay, some solid will be there, this type of white colored solid you can find in the market. If you heat it, that does not, this is solid. Okay, that does not convert into liquid, rather they convert into gas directly. Okay, that is but you can see if it is ice, if you heat it, it will convert into water. Then after you convert it, heat the water further, then it will convert to gas. That means after the solid first convert to liquid, then to gas. But in case of this type of substances, that is your naphthalene, ammonium chloride, iodine or camphor, that directly gets converted from solid to gas when we apply some temperature. That process is known as our sublimation. Okay, so you can write the sublimation from this here. Okay, this will be the topic. Fine. And the solid state of the substance in such case is known as sublimate, and the gaseous state is sublime. That is your camphor. Camphor in the solid state will be known as your sublimate. Okay, and when it converts into gas, then it is known as our sublime. sublime. Okay, and final we have the last topic is our deposition. Okay, deposition, that means it is the process reverse to sublimation. That means sublimation was our solid to gas. Okay, solid to gas was our sublimation, but when gas directly converts to solid, this process is known as our deposition. Okay, it is the process reverse of the sublimation. So you can write from here also the red marking. A process in which a gas transforms into solid, also known as your desublimation, is called our deposition. For example, water vapor changes directly into ice without first becoming into liquid, and this is how snow forms. Okay, when snow forms, the water that is in the liquid, and the gas vapor that directly convert into ice, that is your solid. Okay, that process is known as our deposition. And then in this way, due to the deposition, there is the formation of snow. Okay, or the formation of the clouds, as well as of the frost or hoarfrost on the ground. It is also the artificial process or physical vapor deposition under the thin film of various material. Okay, and deposition releases heat energy, so it is exothermic. So deposition, that means it converts gas into solid. So it is releasing heat energy. So that's why it is said to be exothermic. Exothermic means if something releases heat energy, and if something releases absorbs heat, then it is said to be endothermic. Okay, when something absorbs energy, absorb energy. Okay, so you read it till here. So if you find any difficulty, then we will discuss in the next video. Okay, thank you.